You think you understand big. You don't. Not until you understand that the Earth, this entire planet, every ocean, every mountain, every city you've ever heard of, is smaller compared to the sun than a grain of sand is compared to a beach ball. And here's the part that will actually break your brain. The sun, that massive ball of fire 1.3 million Earths could fit inside, is one of the smallest objects we're about to talk about. By the end of this video, the entire solar system is going to look like a rounding error. Our galaxy is going to look like a single grain of sand. And everything you've ever called the universe is going to look impossibly small compared to what's actually out there. Let's start small and watch how fast big stops meaning anything. Let's start with something you already sort of know. The sun is big, really big. If the sun were the size of a basketball, Earth would be smaller than a pea, orbiting about 26 meters away. Jupiter, the largest planet, would still just be a golf ball, more than a football field away. But here's where it gets uncomfortable. Light, the fastest thing in the entire universe, takes about 8 minutes to travel from the sun to Earth. That's not a long trip, that's just the beginning of our own backyard. Beyond the planets, our solar system doesn't just end. There's a region called the Oort cloud, a shell of icy debris surrounding the entire solar system. So far away that light from the sun takes over a year just to reach its outer edge. And here's the part almost nobody realizes. Some comets that dip into that region take millions of years to complete a single orbit around the sun. An object could be born, orbit once, and return long after every human alive today has been gone for 100 generations. Voyager 1, the fastest, farthest human-made object ever launched, has been flying at over 60,000 kilometers per hour for nearly 50 years. And it still hasn't left the outer edge of our solar system's influence. At that speed, it would take Voyager 1 about 30,000 years just to reach the next star. And that next star, Proxima Centauri, is considered our neighbor. In 1990, on its way out of the solar system, Voyager 1 turned its camera around and took one last photograph of Earth, from about 6 billion kilometers away. In that photo, Earth appears as a single pixel, a pale blue dot, suspended in a sunbeam, smaller than a speck of dust on the lens. Astronomer Carl Sagan later wrote that everyone who has ever lived, every triumph and tragedy in human history, happened on that one pixel. And that photo was taken before Voyager had even left our own solar system. Now imagine trying to find a planet orbiting one of those distant stars. In 2017, astronomers discovered a system called TRAPPIST-1, a small star with 7 roughly Earth-sized planets, 3 of them in the habitable zone where liquid water could exist. It's considered one of the most promising places to search for life outside our solar system. But here's the humbling part. TRAPPIST-1 is about 40 light-years away. That means the light we're seeing from that system left 40 years ago. We are, in a very real sense, looking at the past every single time we look up at the night sky. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. Not planets, stars, suns like our own, most of them likely with their own planets orbiting around them. Scientists now estimate there could be billions of Earth-sized planets in the habitable zones of stars across our galaxy alone. If you tried to count all the stars in the Milky Way, 1 per second non-stop, day and night, it would take you over 3,000 years to finish counting just the stars in our own galaxy. And the Milky Way itself is so large that light, again, the fastest thing that exists, takes about 100,000 years to cross from one side to the other. Everything you've ever seen in the night sky with your naked eye, every star, Every visible point of light is contained in a structure so vast that human timescales become meaningless trying to describe it. But we're still not done zooming out, not even close. The Milky Way is not alone. It's part of a cluster of galaxies called the Local Group, around 80 galaxies, held together by gravity, drifting through space together. The closest large galaxy to us, Andromeda, is on a collision course with the Milky Way. It's approaching at about 400,000 kilometers per hour, and it's already visible with the naked eye on a clear night, even though it's over 2.5 million light-years away. And here's the part that sounds like science fiction, but isn't. In about 4.5 billion years, Andromeda and the Milky Way will actually collide and merge into a single galaxy. Scientists have already given the resulting galaxy a name, Milkomeda. The strange part is that almost no stars will actually crash into each other. The space between stars is so vast that entire galaxies can pass through one another and barely touch. But even 80 galaxies together is barely a rounding error on the next scale up. Galaxies cluster into groups. Groups cluster into superclusters. Our supercluster is called Laniakea, a Hawaiian word meaning immeasurable heaven, and it contains roughly 100,000 galaxies, spanning about 520 million light-years across. Let that sink in for a second. 520 million years, at the speed of light, just to cross one structure that our own galaxy is a part of. And Laniakea itself is just one supercluster among millions of others scattered throughout the observable universe. We are a single star, in a single galaxy, in a single group, in a single supercluster, and there are millions of those. If you think Laniakea sounds impossibly large, there are structures in the universe even bigger that we still don't fully understand. One of them, called the Hercules Corona Borealis Great Wall, is a cluster of galaxies stretching across an estimated 10 billion light-years, so large that some scientists question how it could have even formed within the current age of the universe at all. Given how long it should take gravity to pull material together across that kind of distance. Now for the number that actually stops most people cold. The observable universe, everything we can theoretically ever detect. Given that light has only had 13.8 billion years to travel since the Big Bang, is about 93 billion light-years in diameter. Not 13.8 billion, 93 billion. That number confuses almost everyone the first time they hear it, because it seems to violate the speed of light. But here's the answer scientists give. Space itself has been expanding this entire time. The light left its source 13.8 billion years ago. But the source has since moved much farther away, because the universe kept stretching in every direction. In all that time, and even that 93 billion light-year sphere is just the part we can observe. What lies beyond it, how much more universe exists past the edge of what light has had time to reach us from, is something we may never be able to answer. Some physicists suspect the true universe could be hundreds, or even thousands, of times larger than what we can ever detect. Others suspect it could be infinite, and here's something wild. The actual edge of what we can observe isn't empty space. It's light, the oldest light in existence, called the cosmic microwave background. It's the literal afterglow of the Big Bang itself, stretched out over 13.8 billion years until it cooled into faint microwave radiation. If you've ever seen static on an old analog TV, a small percentage of that static was actually this ancient light, hitting the antenna after traveling across nearly the entire observable universe to reach you. Some physicists take the strangeness even further. A number of respected theories in cosmology, not science fiction, but serious peer-reviewed physics, propose that our universe might not be the only one. under certain versions of inflation theory. The same process that caused the Big Bang could have happened, and could still be happening, in other regions of space we can never observe, each one becoming its own separate universe with potentially different physical laws. We have no way to prove or disprove this yet. But the math that predicts our own universe's structure doesn't rule it out either. Here's something that makes all of this even stranger. Everything we've talked about so far, every star, every galaxy, every planet, only accounts for about 5% of everything that exists in the universe. The remaining 95% is something we still don't fully understand. About 27% is called dark matter, something that has gravity. That shapes how galaxies spin and hold together, but that we've never directly detected or seen. The other 68% is called dark energy, a mysterious force that appears to be accelerating the expansion of the universe itself, pushing galaxies apart faster and faster the longer time goes on. In other words, almost everything that makes up the universe is something science still can't fully explain. Here's the strange comfort in all of this. Every person you've ever met, every war, every empire, every book ever written, happened on a single small blue dot, orbiting an average star, in an average corner of one galaxy, among at least 2 trillion others. And yet, as far as we currently know, that small blue dot might be the only place in the entire, unimaginably vast universe where anything is aware enough to even ask these questions in the first place. That's not a small thing. That might be the strangest, rarest thing in all 93 billion light-years of everything that exists. The universe doesn't just get bigger the further you zoom out. It gets stranger and somehow more humbling. We are impossibly small, and also somehow impossibly lucky to be here to notice. Every scale we covered today, the solar system, the galaxy, the local group, Laniakea, the observable universe itself, all of it existed for over 13 billion years before anything anywhere was capable of understanding any of it. And then on one small planet, orbiting one average star, something changed. Matter organized itself into something curious enough to build telescopes, calculate distances, and ask, how big is all of this really? That, on a cosmic timescale, might be the single strangest event we know of. Beyond the visible, beyond what you can see, but never beyond what you can understand. Subscribe because next time we go beyond again.